Now, interpretation of the TT diagrams. What are the interpretations? So first one, you can say the transformation start and finish curves. Okay, I mean where the transformation occurs. I mean you have a sufficient at a temperature at which your transformation will start. Okay, and the transformation will end at a particular temperature, and then the new phase will having a temperature which will be taking the latent heat of you can say fusion. Okay, or just a latent heat. Okay, so the curve indicates the time required for the transformation of austenite to begin and complete to the given temperatures. The nose of the curve represents the temperature at which the transformation starts occurs most rapidly. Here you can say the nose, this kind of a thing. This here you can say transformation occur very rapidly. Okay, now the cooling path. Second one is, yeah, cooling path. So slow cooling which result in the formation of pearlite. Moderate cooling result will be formation in the bainite. And if the rapid cooling, then we are having the martensite. Why? You can see, suppose you have a your temperature here, right? Your material is here, and you can say here you have zero values, or you can say ambient temperature, not zero value, but here you are having ambient temperature. Okay, here you have your furnace temperature, where you have already make your material at temperature. You can say furnace. Okay, so here we have furnace temperature. Now if you can directly jump to the rapid cooling here, then you would be having the martensite. If it would be slow cooling, then you must be having the pearlite. Okay, if you have the moderate cooling, which means you are I mean you can say what means the slow cooling. Slow means you are just providing them to cool inside the furnace. You can say annealing. During annealing, you will be having the pearlite. But if you are just not providing them to cool inside the furnace, rather than you are providing an normal environment temperature to the material so that they can cool down. So that would be having the bainite. Okay, here you have just kept that material into the environment, and they are just decreasing the temperature due to the environment transformation of heat. Okay, so here what we will be getting bainite. But if we are just rapid cooling means like quenching, here you just remove the material from the furnace and you just put inside the oil or water, so they will cool down very fast. So that nature of cooling will provide you martensite. Okay, and so and we know, we have already discussed that during the quenching we must be getting the very high hardness, and due to the high hardness the brittleness will be increased and ductility will decrease, so that you can conclude that the martensite is just a hard, very high hardness, and leads to the brittleness and having the low ductility. So if you know the correlation between how if a hardness, brittleness, ductility, softness, these, if you have just a clear idea about that, then you can easily correlate if you know only one thing. Here you know that it is having the rapid cooling. Rapid cooling means they are just jumping from high temperature to low temperature. It means their hardness will increase. If hardness will increase, their brittleness will increase. Their toughness will, we cannot say directly. They can decrease or decrease. Most of the time it increase, but ductility always decrease. Okay, so it depends. And here, if if a slow cooling, or you can say if it's just annealing, then we would be having the pearlite. And if we are getting the pearlite, it means the ductility will be high, the brittleness will be less, and the hardness would be less. Okay, similar to that, if we are having the bainite, so in between that we have the moderate cooling. So we can just conclude that in whatever the property that we have gotten in martensite, and whatever the property that we have got in in uh, pearlite, that would be that bainite would be the in between that. Okay, so whatever the property that we are getting in that too, that would be in between in moderate cooling. Or you can say for the bainite, their property would lie in between pearlite and martensite. It is just a kind of correlations. Critical cooling rate. Okay, so the critical, or you can say cooling rate must be exceed the critical cooling rate to avoid the formation of pearlite and bainite and achieve the fully martensite structure. So what the cooling rate means, you can just directly jump to the, I mean you are not going in between having a Pearlite and Bainite. So you are interested to get only Martensite. For that, we must having the rapid cooling because we are interested to skip these two formations and we want to come into directly Martensite. So to have the Martensite directly from Austenite, we must have to go on. We must have to skip the between middle process or intermediate process, that is the Pearlite and Bennett. And for that, we are having the quenching process. We are having the rapid cooling. Whatever the rapid cooling options that we are having, we can use that so that we can directly jump to the, or we can directly convert all the austenite into the Martensite. That is known as critical cooling rate. Okay.